Okay, good morning, you guys. Today is Tuesday, October 13th. Hopefully, you guys can see this. The notes are right here. It is kind of a cloudy, rainy day right now while I'm recording this. So, as we get back into things here, as we get into kind of our new normal for at least this week here, basically, I'm going to just explain a couple things to you. Number one, if you have your notes notebook, if you brought that home, hopefully you guys brought home basically everything that you would potentially need. If you want to, you can be filling these notes in. You can be copying, following along and copying along just as if we were in an ordinary class, okay? So if you want to, you can just kind of copy these notes into your notebook. You can kind of pause the video as you need to get things copied down, but you don't necessarily have to. These will be things that you can look back at, but if you're anything like me and you're super organized and you like having kind of your set routine, your set normal, then by all means copy these notes down into your notes notebook, okay? So it's been quite a while actually since we've even cracked our notes notebook because, prior to today, if you think about everything that we've done in the last week and a half, we took the quiz. Once we took the quiz, we started kind of going back through the recap stuff. So we went through the review of everything that was on the quiz. Then we had a couple days off last week. And then yesterday was obviously a day designated for those that still had to take the quiz or needed to do the retake on the quiz. So it's been quite a while since we've actually been in a normal math class or doing normal math class things like taking notes, getting an assignment, working on assignment, asking questions, stuff like that. So again, this is kind of up to you guys entirely if you want to copy these into your notes notebook or if you just kind of want to follow along and then use the video to get going on the assignment. It's entirely up to you. Just make sure you're keeping up on things for these next 4 days at least while we're separated, okay? So you can see we're going to jump back into chapter 1. So this is actually wrong. I'm pre-recording this. Today is the 12th, but you guys are watching this on the 13th. Okay, so 10, 13, 20, section 1.6 is titled Systems. It's actually titled Systems of Equations, but systems will suffice if you're copying these notes down. So what we're going to see today, what we're actually going to see the next 3 days, we're going to be on this section for 3 days here. What we're going to see is something that we saw in Algebra 1. Okay, so it's been a little while since we've seen this specific concept, which is systems of equations, but what you're going to see is it's all relatively basic algebra skills. Okay, so the first thing that you can see I have here is the definition of what a system of equations is. A system of equations is just simply a single math problem, so one problem containing two or more equations. So it's kind of a very fancy or formal term for something relatively simple. It's just for us, for now, it's two problems combined together, or two equations, I should say, combined together in one example or one problem. So you can see right here, this is an example of a system of equations. Okay, this is one example that has two separate equations, 2x plus y equals 7, y equals 1/2 x plus 2. Okay, so two separate equations, each equation has an x and each equation has a y. All right, now what I'm going to show you first is I'm going to try today to really explain well what we're doing. Okay, the how we're going to do it is the part that you're actually going to do on your assignment, but the what we're doing is going to hopefully make the next 3 days make a lot more sense. Okay, so what we're doing is basically this: we're taking single problems that have two separate equations and we're trying to solve them. Okay, so if you just kind of stop and think, and I go, this is kind of one of those times in class I'd say, look at me, don't look at the board. What does the word solve mean? The word solve means solve for x, or solve for y, or solve for whatever the variable is. Okay? So this first example is not actually an example of what your homework is going to be like today, but it's just to kind of get you guys really thinking and understanding what exactly it is that we are doing. If you look at this first set of directions here, it says, is the point 2, 3 a solution to the system? So for a lot of people, that kind of makes it seem a little bit confusing. Like, well, I don't even really necessarily understand what that question is asking. Well, when we boil this down and when we really think about it, what is the point 2, 3? The point 2, 3 is just a condensed or shorthand way of saying this. is x equals 2 and y equals 3. These two things mean the same thing. The ordered pair 2, 3 and x equals 2, y equals 3 mean the same thing. This is just a shorter way of writing this. So what this is actually saying is x equals 2 and y equals 3 a solution to the system? So again, if we just think very simply in plain terms here, how do we check solutions? How do we answer questions where it says, is this a solution? The way that we check solutions is by plugging them back into the original equation. So literally, to test this point, or to test 2, 3, we just plug them back in. So like I'm going to take this equation right here, the 2x plus y equals 7, and I'm going to plug in the two solutions that it gave me. So I'm going to plug in for x here, I'm going to plug in 2. Okay, so x is 2, and then where it says plus y, that's going to say plus 3. And literally all we're going to do here is we're going to check it. We're going to see if it actually checks out. So right here, 2 times 2 is 4. There was no coefficient in front of y, so I really don't need those parentheses. I can just kind of drop the parentheses. It becomes 4 plus 3, which is obviously 7. So we get 7 on both sides, so we say it checks out. Okay? So put simply, here's where we're at right now, you guys. At this point, we know that 2, 3 is a solution to the top equation, 2x plus y equals 7, because it checks out. But now, to be a solution to the system, it says is 2, 3 a solution to the system? Basically what that means is it's got to check out for both equations. All right, again, a system is just two equations in one problem. So to be a solution to the system, it's got to be a solution to both equations. So we do the exact same thing here. We go y equals 1/2 times x, 1/2 times x plus 2. I gotta make sure you guys can see this on your camera. We're good to go. All right, now again, this was y. I'm going to plug in 3 equals 1/2 times x, plug in 2 for x, and then do the exact same thing that we just did. Just test it out. This side is 3. Over here, 1/2 times 2, half of 2 is 1. Bring down the plus 2. 1 plus 2 is 3. We get 3 equals 3, so it checks out. So what we've established at this point is the point 2, 3 checks out for both separate equations. So if you had a question like this on the assignment today, the answer would be yes. It checks out for both equations, which means it checks out for the whole system. Okay? Cool. Now, the issue is this is not actually what they're going to do today. They're not going to give you the possible solution and just simply ask you to check it, okay? Instead, what they're going to do is they're going to give you this system today, okay, two equations, and they're going to ask you to solve the system. Now, there are 3 methods for solving a system of equations. So solving a system of equations. Those are the 3 days that we're going to spend on this section. All right, we're going to look at doing these things 3 separate ways. All right, the first way, which is the way that you're going to be doing it today, and I got to talk a little bit about this. This is where, you guys not being in school is going to be a little bit of a pain in the butt, and I'll explain that in a second. But the first way of doing this is to solve by graphing. Okay, so what you guys are going to see today, and here's kind of going to be the pain in the butt. Unfortunately, you are going to have to freehand draw your graphs today, okay? So in terms of like graphing these, what we're literally getting at, and this is kind of why this makes perfect sense, you'll see here, I'm going to bring down the bottom equation first, y equals 1/2 x plus 2. What you're going to notice is this is a direct carryover from what we just took our quiz on. This is a linear equation in slope-intercept form. Y equals 1/2 x plus 2 is an equation that is ready to be graphed. It has a y-intercept of positive 2. So to graph this, we would start by going up and putting a dot at positive 2. And then from there, I have a slope of 1/2. So I have my slope is 1/2, where obviously slope when we're graphing is rise over run. So from that 2 that I just put, I need to rise 1, run 2. So I'm going to rise 1, run 2, put another dot right there. And then I'm going to draw that line in. Okay, so I have a ruler here. You guys can use any straight edge. You'll obviously, like I said, The real pain here is you're going to have to just freehand draw your sheets of graph paper. I don't have graph paper that I can obviously send to you guys. Even if I did, you'd have to have a printer to actually use it. So it's just kind of the way that it's going to go today. All right, guys? Now, if you look at the other equation, 2x plus y equals 7. This is an equation that needs to be converted into slope-intercept form. So I'm going to put bars over my equal sign, and we're going to do, we've done this extensively. This is what we did in section 4 and 5, writing equations of lines. So I'm going to subtract 2x from both sides. I'm going to bring down my y equals, and now on this side, all I have to do is bring these two terms down in the correct order. I need to bring down the negative 2x first, and then the positive 7 second. And if you look at this, that is now in slope-intercept form, just like my other one originally was. I have a y-intercept of positive 7. So here's 1, 2, 3, 4, 5, 6, 7 on my y-axis. There's my 7. My slope is negative 2, so I need to put that or write that as a fraction, turn it into a negative 2 over 1. And now here's what I'm going to do. I'm going to go down 2, right 1. So I'm going to go down 2, right 1. I'm going to put a dot right there. And then I'm going to draw in that line. Oh, there it is. Misplaced my ruler there for a second. All right, now here's what you guys are going to notice. When I draw this line, what we obviously have here is we have one graph that has two lines on it. What you will notice is this. The point, or they have a point of intersection. The point of intersection is that point right there. It was the second point from my first line that I graphed. What you're doing today is this. You are going to graph your two lines. And what you're going to look for is you're going to look for the point of intersection. If you think about that, and this kind of is where it's going to hopefully make sense to you guys because we did this kind of introductory example. That is the point from the origin over 2. So I have an x-coordinate of 2. And then it's up 1, 2, 3. So it has a y-coordinate of 3. It's the point 2, 3 that we were checking in this first example. Okay, you guys? That is the point of intersection. That is how we find this. That's how we solve this, right? We solve this system. We figure out that x is 2 and y is 3 in both of these equations. Both of these x's have to be 2's. Both of the y's have to be 3's in order to get this system to check out, okay? But the method that we use for finding that when we're not given the point to plug in is we graph both of the lines and we find the point where they intersect. Now, I'm fully aware that with you guys freehand drawing your graphs, your graphs might not look perfect. Just go to the closest point. So if you're looking at yours, you're like, it kind of looks like it's in between points. Just go to the closest one. What you guys are going to see and what we're going to talk about tomorrow is the fact that graphing is the least effective method for this. Okay, so graphing is not a terribly accurate way of accomplishing this, but it is kind of the first way and the way that makes the most sense leading in from what we were doing last week. Okay, so this is going to be the entirety of today's portion of the assignment. You're going to be given a system of equations here, and you're going to be asked to find the point that they intersect at. Even though it's not going to say find the point of intersection, it's going to say solve the system by graphing. Okay? But that's essentially what you do. You try and find the point where they intersect. So I'm going to show you just a couple more examples in the time that we have left here. Here's going to be our next one. What you will notice is you're going to hope that all your equations work out nicely or start out nicely in slope-intercept form. So y equals 2/3 x minus 1. And then here's going to be my other equation. 2x minus 3y equals negative 3. Actually, hold on. Let me change that one just a bit. Let me make this, let's go negative 6. All right, perfect. All right, and again, you're going to have to freehand draw your graphs for today, but don't worry, we're going to get out of or get away from graphing moving forward. Okay, so here's kind of what I just mentioned. This top equation is nice because it's already in slope-intercept form. So negative 1 is my y-intercept. I put a dot at negative 1 on the y-axis. My slope is 2/3, so from that point, I go up 2, over 3. So I go rise 2, run 3, put a dot there, and then draw our line in. Okay, there's that one. And then what you're going to notice is that some of your equations are going to start out in slope-intercept form. Some of your equations you have to convert to slope-intercept form. So here's one, just like up here, I have to convert it. What you're going to see though is we've already talked extensively about the steps here. You start off by subtracting the x to the other side. You move the x to the other side by completely getting rid of it. Now here I do have a coefficient of -3, so I need to bring down -3y. On this side, I need to bring down the x term first. So bring down -2x first, and then -6 after it. So I brought down -2x, then I brought the -6 down after it. And the last step for getting y by itself here is divide away the coefficient. Divide everything by -3, and then here's what you're going to get. Break apart this compound fraction using our Hart method that we've done quite a few times here. This will give you your slope. So what do you notice about your slope? Well, for starters, the negatives are going to cancel. It's negative over negative, so it's just positive 2/3. Bring down the x. And then your y-intercept is going to be -6 divided by -3. So again, a negative divided by a negative is a positive. 6 divided by 3 is 2. Now, here's again why this makes so much sense to be basically a spin-off or the follow-up to what we just took our quiz on. What do you notice about this equation? Well, most people are simply going to say it's got a y-intercept of 2, so you put a dot at 2 right there. It's got a slope of 2/3, so that's a rise of 2 and a run of 3. So from that 2, rise 2, run 3. But some of us will notice right away, before we even draw our line in here, they're going to be parallel. How did we know those lines were going to be parallel right from the get-go? Well, remember, this one had a slope of 2/3 to start with, and this one ended up with a slope of 2/3. We talked about that in section 5 a whole bunch. Parallel lines have the same slope. Well, that's kind of problematic here if you're thinking about what our goal is, because our goal is to find the point where those two lines cross. That's the solution to the system. That's the solutions for x and the solutions for y. So if these two lines are parallel, they have no point in common. They have no point of intersection. Well, that means they have no point that's going to be a solution to both. So what we literally would say in this instance is that there are no solutions. Okay? Now, I want to show you, I want to kind of wrap this up relatively quickly here. I want to keep our videos at about 20 minutes or less. I want to show you just one more quick example here, and I'm going to kind of use these similar numbers here. What if I would have given you this one? Y equals 2/3 x minus 1, that same equation that we started with there. Okay, so there's y equals 2/3 x minus 1. It's this line right here. But what if I would have changed this one just a little bit? I would have made it 2x minus 3y equals 3. Okay, how would that have impacted this problem? Well, we won't notice it right away. We'd say we still subtract 2x from both sides to move it to the other side. We bring down -3y. Over here, we bring down -2x first, and then our positive 3. So I put plus 3 right there. We still divide away our coefficient, so we still divide away -3. But now watch what happens here. When you do that, that gets y by itself. So I'm going to pull this one over here. Y equals. You still break apart your compound fraction using your Hart method right here. So -2 over -3, the negatives still cancel, so you're still left with 2/3 x. So most people would look at this and they'd be like, wait, parallel lines, so it's no solutions. But wait, this actually ends up being, when you look at your y-intercept, it's positive 3 divided by -3. Well, positive 3 divided by -3 is -1. What we end up realizing is this. These two equations are actually identical, which means instead of getting a parallel line right there, this is actually the exact same line. So what this means is this is one problem with two different equations, but the two equations are identical. That means if you were to draw both of these lines, you'd just be redrawing the first line. So this is actually, instead of two parallel lines that have no points in common, this is two lines that are smack dab right on top of one another. Okay, guys? So if you think about this again, I'm going to wrap this up in just a minute here. If you think about this, this isn't two lines that have no points in common. This is two lines that are smack dab on top of each other, that have all their points in common. Now, we don't want to say all solutions or all numbers, but what we do want to say is we want to say that these two lines are on top of each other, so they have infinitely many points in common, or infinitely many points of intersections. So we say they have infinitely many solutions. Here's your three scenarios, you guys. Either your system of equations creates two lines that cross at one point. If they cross at one point, that point is your solution, okay? The other two scenarios is you could have two equations that end up being parallel, which have no points in common, so no solutions, or you can actually end up with two equations that are exactly the same equation, which means it's two lines stacked on top of each other, which have infinitely many points in common, so infinitely many solutions. Okay? These are the only three scenarios that you're going to run into. One solution, no solutions, or infinitely many solutions. All right, guys? So that'll do it for today. Hopefully this stuff is relatively easy, especially after going back through and reviewing and recapping all of that, that first quiz information on drawing lines and writing lines of linear equations and stuff like that. So hopefully we really don't run into any major issues with this. It's pretty simple and straightforward. So just knock out the assignment, get it sent to me, try and get into a really good routine and rhythm with this, this virtual learning. I think you guys will end up, if you're responsible with it, you could end up, getting done with all your schoolwork in a shorter period of time than what a full school day takes. But you definitely are going to have to work hard while you're learning remotely. All right, guys, that'll do it for today. Have a great day. I'll talk to you tomorrow. Please let me know if you have questions, okay? Just shoot me an email, and we'll get the questions worked out.